All right, folks, it's Bass Action back in action here. In this video, we're going to go through three major ideas. We're going to talk about exponent rules, scientific notation, and then solving linear equations with fractions, but then labeling our work as we go along. You will notice that I've already filled these notes out, and I'm going to talk through my thought process. So you will likely need to pause this video as you go along so that you can actually write this stuff down. You should don't just watch, definitely write these things down. So let's take a look at this first problem. We want to simplify this expression. What we want to notice here is that we have several things going on. We've got some coefficients in the front, we've got a variable of x, and then we have our variable of y. Now, with the coefficients in the front, I just reduced that. So 5 over 30 gave me this 6. I didn't bother writing the 1 in the top. For the x's, I looked at these exponents and I subtracted them. So 5 minus 3 gave me my x squared. It's in the numerator because conceptually you can see even that we have more x's in the numerator than the denominator. Now for the y's, I went ahead and I did a middle step. What I did is I took this y to the negative 2 and I rewrote it in the denominator just as a middle mental step for myself. So once I write that in the denominator, now it's easier to see that these two are going to combine. And of course, that other y does have an exponent of a 1. So these are going to get added, and that's where my y cubed came from. On this next one, we've got even more stuff happening here. Again, we've got our different components. We've got our coefficients out front. We have our x's again. This time I've got this whole expression that is to a negative power, and then I have the random y that's sitting there in the denominator. Let's take a look at the coefficients first. This negative 2 squared, this exponent of 2 only applies to the 2. It doesn't apply to the negative. So when this gets cleaned up, it's actually a negative 4 here. It is not positive. These then will reduce, just like we did this, to give us this negative 2 here in the numerator. Here, with this x to the negative 2, I did the same thing that I did on the last problem. I took my x to the negative 2 and I moved it to the denominator. On this portion here, I did two things. First of all, the whole thing is negative, so it's all going to go to the denominator. The other is that I want to recognize, didn't mean for that to be a highlighter, is that that's going to distribute. So this becomes a y to the first in the denominator and a z to the first in the denominator, and that's this right here. These are the original remaining two components that were right here. So now for my final answer, what I did was I combined my x squared and my x fourth. X to the fourth gave me x to the sixth. Then I took these two y's, and that gave me my y squared, and then of course the remaining z. So that's that final answer. Now, on our last two problems, these are called rational exponents, okay? Rational exponents are what you can think of as the fractional exponents. They are just a fraction of two integers. The trick to working with these problems and making them easily able to do without a calculator is to look at the denominator. Keep doing that. Look at the denominator of each of the rational exponents. If you rewrite the base using some number to this power, they will clean up nicely. So for example, 4 is 2 to the second power. So 2 to the second power, now these exponents multiply. So 2 times 3 halves is 3, and 2 cubed is 8. Over here, I'm looking at each of these components, the numerator and the denominator, and I want to write them as something to the third power. So 27 is 3 to the third power, using that exponent. 8 is 2 to the third power, again, using that 3. Now, these exponents multiply, leaving me with a 2. These exponents multiply, leaving me with a 2. So my final answer, 3 squared is 9. 2 squared is 4. Now, on our next part, looking at scientific notation, we are going to ultimately come back to these exponents. On our scientific notation, what we want to think about is that something times 10 to the 6. 10 to the 6 is the big number. So this is our clue of what way this decimal point should move. We want this number to be big, so it's going to move to the right. Versus this problem, when we write it in scientific notation, this is really, really small, so its exponent when we're done should be negative. The way we're going to do this is we're going to use this exponent here. We're going to move this decimal point 6 places. So 1, 2, 3, 4, 5, 6. And then you can physically draw in those zeros. So our answer is 3, 8, 9, 2, 1, 2, 3. And then you can put those commas in. This one, what we're going to do is we are going to count how many places it takes us to get to right here. We want to be just to the right of the first non-zero value. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So now when I get 7.325 times 10 to the negative 9th. Okay, now we're going to combine these ideas on this next problem, working to evaluate this problem without a calculator. And again, I've written everything out so I can kind of talk through what I'm doing. So the first thing when we look at this step over here is where did the 7 and the 560 come from? And what I did is I looked at these two parts right here, the 700,000 and this 56 million. And I first just got rid of all these extra zeros. So I have 5 zeros here, and I can get rid of 5 zeros here. And when I do that, that leaves me with the 560 and the 7. That's where those came from. Now, when I go to here, I'm working with this numerator, and I can simply multiply the 7 times the 2. Now, sometimes what it might be helpful for some students to see this as is 7 times 10 to the 0, because 10 to the 0 is a 1. So that means that the 7 and the 2 give me 14, and then when I multiply these, this is going to give me 0 plus negative 12 is negative 12. Now, my denominator is a little tricky. I didn't want to introduce decimals here because I'm trying to work without a calculator. So this 560, instead, I wrote it as a 56 times 10 to the first. Because if I do that, 14 and 56 will reduce to 1/4. And then negative 12, and the exponent of 1, negative 12 minus 1 gives me negative 13. Now I'm going to switch to decimals. 1/4 is 0.25, and now I'm back to what I just did on the last problem. I'm going to move that decimal one place, move it to right here, and that gives us our final answer of 2.5 times 10 to the negative 14th. You're probably not going to have to do that a lot, but it is a combination of all the skills that I think is worth seeing. I will tell you, put a big star on this one. Okay, this is really important. Students misread their calculators all the time on this. Okay, if you have your calculator in front of you, we're going to enter this into our calculator. 1 divided by 9 to the 5th power. When you do that, you're going to get something that looks like this. Most likely your calculator is going to show you this E. This E is telling you that the exponent is a negative 5. They're telling you this is a scientific notation. So when we want to write our answer in scientific notation, that part stays the same, and then we need to write the 10 to the negative 5th, so times 10 to the negative 5th. The last part is exactly what we did up here, and we're just switching it back to what we call the expanded form. The last thing that I want us to look at here is solving this equation, working with our fractions. So I've already worked this out, but we are going to write down what exactly did I do. You would have done this in your geometry days. So the first thing that I want you to notice is that this problem with fractions can be difficult to work with, okay? What we want to always do is multiply by the least common denominator. So what I did on this problem is I took the entire problem and I multiplied it by 21. So my reason for how I got from here to here would have been the multiplication property. And we can just write multiply, okay? That's fine. Now, let's talk how that worked. This 21 got distributed to this entire problem. So it got distributed there, it got distributed to this whole piece, it got distributed here, and it got distributed all the way over to here. So 7 went into 21 3 times, and then 3 times 3 was our -9, not losing that negative. 21 times -2 was my -42, and then 3 went into 21 7 times, and then 7 times 7 was our 49. And then we still have the x minus 10, and then another 42 right here. Now for the next step, when I go from here to here, this whole left side is staying the same, but I can see that I am distributing. So this is distributing, or distribution. On the next step, from here to here, I can see that I've combined these like terms. So we're going to call this simplify. From here to here, I can see that I've moved this 48 to the other side by adding 48 to both sides, -448 I meant to say, and then I've added 9x to both sides. So we're actually going to call this addition subtraction. You can think of those two as together. The next thing I did was I did multiplication division. Depends how you want to think about that. And then our last one is this weird little tricky thing. Again, you're probably not going to see it very often. This is the symmetric property. Probably have forgotten that from your geometry days, but it just means that we can rewrite this in either order, flipping the both sides of that equation.